But the thing is, use SSL pinning, because if you do not have like access to the API's information, like from where the call is coming, from the header of the call, you will basically find out in the end of the month that you paid a lot of money, but you have a very small user base, or maybe you have a large user base and you will not even care about that $1,000, $2,000 extra of like expenses. So let's see how SSL works. So, hi everybody. I'm so happy to be here today in my home country, back in my home country at SwiftUI. So today I'm going to speak about securing iOS applications with SSL pinning. So let me briefly introduce myself. I'm Pietro Messineo. I do work for Bluethrone. I actually wear several hats because I do have like a lot of things ongoing. I'm tech lead and senior iOS dev over there, but I do work also for Purple Technology, which is a fintech company. So I'm iOS developer as well over there. So we do have a lot of open position if you would like to join. Yeah, maybe React Native developers is not for you, but we may have like some iOS position as well in the future. I do also some like indie development and consultations and some other clients as well. So let's start. Let's talk about app security requirements. So as you can see from this graph, we do have like several requirements in order to have an app secure. So first of all, it's data storage. So it covers like a lot of protective, like protection-sensitive data, such as authentication, tokens, and private informations. So that's one of the things that you should keep in consideration when like building a secure app. Then you also have like cryptography. So you would like to keep like all the cryptography, like, you know, best practices in order to avoid some unsecurity issues. Then authentication and sessions, such as like local PIN authentications, you know, when you have to type the PIN or just do the biometric identification through Face ID or the old outdated Touch ID. Then we have also network communication, that is what we are going to focus today. So I'm talking about best practices for integrate SSL, pinning, and some other safe communications between API, our REST APIs, and clients itself. And then some platform interactions, so just platform, like usage of platform APIs in a safe way. Code quality, that is basically done by the usual security things from the code itself. And resilience, so we want to make our app safe from like possible attacks through jailbreak and reverse engineering. So let's talk about SSL pinning. What is SSL pinning? How many of you knows what is SSL pinning? Just raise your hands. Okay, cool. A lot of people knows like this, but yeah, we will see later how many of people are using it actually. So SSL stands for Secure Socket Layer. And basically, it's like the SSL certificate pinning is the process of associating a host to its like public key or certificate itself. So once you know the host certificates or public key, you can pin it to the host and you have like a secure connection between those two things, like client and the server itself. So why do we need SSL certificate pinning? First of all, because we want to protect our application against man-in-the-middle attacks. So as you can see from this graphic, you have like a server, then you have the SSL certificates, and then there might be somebody in the middle, like me, that can like give you a bad certificate and or a modified version of the certificates that basically will cause some trouble to the app. Which type of trouble we are talking about? We could do interception of network traffic, or we could even manipulate the traffic itself. So what does it mean, intercept network traffic? Usually we do have like API that are REST API in JSON. So this means you receive like a block of text, you parse it and so on. But if you do not use SSL pinning, you just give it to everybody in plain text, or at least to the man-in-the-middle guy, me. in this case. And you can even manipulate that on the fly. So once you receive the REST API response, you can manipulate it and do something in the code. Well, now it's like time for a funny story. It's a story, so don't think that it was on me or that I made it, but it's just a story. So back in 2020, a developer was creating an app. And he was just having a look at the, other concurrent applications and like competitions. That's what you usually do. I want to build an app and there are like competitions. So he just did like this man-in-the-middle attack, and he found out that this application was like contacting some provider, right? Because he wanted to build the same. So he was like, oh yeah, I want this API. But he found out pretty quickly that they weren't using SSL pinning. So he found the token that they were using, and he just created the same app and used the token of the other people. So he wasn't having any expenses and earning a lot of money from it. That's not me, of course. I mean, I cannot say that it was me, but the thing is, use SSL pinning, because if you do not have like access to the API's information, like from where the call is coming, from the header of the call, you will basically find out in the end of the month that you paid a lot of money, but you have a very small user base, or maybe you have a large user base, and you will not even care about that $1,000, $2,000 extra of like expenses. So let's see how SSL works. First of all, you have like the client that is our iDevice, and it sends a connection request to the server. So the server listens this request and gives a response. So it's included the public key and the certificate. Then the client is checking the certificate and sending the encrypted key to the server. I mean, it's sending an encrypted key. Then the server is decrypting this key and sends the encrypted data back to the client. All right, so all good so far. And then once the client receives and decrypt the encrypted data, it's basically what we do. We display whatever we want from the API. All good, but if you don't implement SSL pinning, all of these things are useless, because once you get the certificate and the public key, if you do not do anything, I mean, if you are not like performing SSL pinning, you are not doing the last two steps, and you are just getting these things in plain text, so it's kind of useless. Let's try to see which are the types of SSL pinning that we have. As I said before, we have certificate pinning and public key pinning. So the certificate pinning is basically, we store the certificate into the app bundle, and when there is the networking call, we check if the certificate is like the same, the one that is coming from the server. And then we have the public key pinning. So we extract from the certificate itself the public key, and then we compare it to the one that is coming from the server certificate. So you do not have to store actually anything in the code itself. So the certificate pinning, of course, is not ideal, because you have to update the application in case of expiration of the certificate. But instead, with the public key, you can just, it's just not changing when the certificate is expiring. So which method like you should use? As I said, certificate pinning is the easiest, because you just take the certificate as it comes from the server, you put it in a bundle, and then you compare it. But of course, it's less flexible, because you have to change the certificate. And if the server changed the certificate, of course, it will not work anymore. And then you have like the public key pinning, that is the one that we're going to see today. And if the certificate expires, the public key remains unchanged. So basically, they just refresh the certificate, and the public key is always the same. So at this point, you are asking to yourself, am I safe implementing this? Absolutely not. Because there are some ways that allows you to bypass the certificate pinning. For example, you can install some SSL kill switch like softwares or Barcode Mobile Assistant, but those are available only for jailbroken devices. And, or you could use, for example, Objection and Frida, or some disassemblers like Hopper or IDA in order to decompile the app and do some changes to it. So one important thing to know, how many of you knows like what is jailbreak? Okay, not many people. I mean, I feel old, even if some of you are even older than me, but okay. I mean, Jailbreak is like pretty important in those SSL pinning and pen testing and so on. It's kind of complicated nowadays to implement it, but yeah, hopefully Objection and Frida should do like the same job in order to decompile and see. I will show you later, like as an alternative to jailbroken devices in order to do some pen testing. So let's see how Objection and Frida works. So basically, we have dynamic like toolkit for developers, and it allows you to do some reverse engineering and some security researches. I'm not gonna like explain it deeper because it's not the purpose of this presentation. But Objection is basically a wrapper for this framework that can do most of the works for you. So you do not have to do like old school and dig into the code and decompile it and so on and so on and so on. So in order to analyze or replace the certificate and bypass the SSL pinning, we need to put the Frida gadget library into our application that we want to exploit it, right? So how can we do that? First of all, we need to extract the IPA file. You can find it online, or most likely you can even like use some extra software that allows you to get the API for you. Then we have to modify the binary in order to load this dlib, that is the Frida gadget dlib. And then we have to code sign the binary and the dlib itself. There are so many software out there that can do this, but fortunately, it's like automatically doing for you. And through the objection, so we can basically repack the new version with the Frida gadget dlib, and then we can install it back. So you can use any iOS deploy tool. I don't know if you are like aware about sideload. It's something that is probably coming with iOS 17 open to Europe because Apple just lost some codes. Basically, you can use CD Impactor or sideload leaf for put back your application and sign it if you have a developer account. You can just sign it by your own. So that's one of those things. But is there a way actually to bypass the certificate pinning? Yes. We can basically prevent it using some obfuscation of Swift and Objective-C metadata. So name obfuscation, or we can rename the methods in order to make them like harder to understand what they are doing. And it's something that I actually found in one of the apps that we recently bought in Bluethrone. Basically, they do use Firebase, and the namings are insane. It's just letters. So I was like, okay, what this is doing? I mean, letter A, letter B, what the hell is this? So it's actually, I mean, why they did this? I think just because there is no Peter, the other speaker. Peter? No. Yeah, he's in the other room. Bad for him because he's like a developer advocate of Google, and I wanted to tell him that they do not use SSL pinning. So you can have like all the Firebase remote config and everything in plain text, and most of developers are using this for check their paywall, when the paywall should be active, when it should not be. And basically, if you can modify this on the fly, you can have a unique offer to the app and have maybe lifetime access for a quarter of the price. Anyway, just for come back to the topic, that's why maybe this new company that we bought in Bluethrone is like assigning weird naming to their variables because it can be available to anybody. And imagine if you do SSL pinning and then you find that into the Firebase Firestore there is like the access token or the notification token. So you can get that and send just push notification to the user with some link or something, and you can do whatever you want. So another thing that you can do for prevent bypassing on certificate pinning is also I'm lost, sorry, too many things. Anyway, let's dive into how to perform SSL pinning in iOS. So first of all, you can use like several networking tools, for example, URL session, like as a framework, or Alamofire, or AF networking, and TrustKit. Personally, I recommend to use URL session instead of Alamofire because why you should go to third-party frameworks if you can do everything with URL session, but actually you cannot really do everything because, for example, I'm developing an app and it was requiring to have event stream, and URL session doesn't support event stream. So you guys have to fallback in Alamo Fire, kind of pain in the ass. So TrustKit is like underlined just because it's what we're gonna see today for perform the SSL pinning, basically. So what is TrustKit? It's basically an open source framework that is available widely for any type of like device and platform. And it's supporting probably iOS 13 nowadays because my slides are outdated, but they keep bumping older version of Apple OS. And it supports like Swift and Objective-C, and it allows you to do easily public key and certificate pinning on those operative systems. So why should we use TrustKit? First of all, because it's provides a very easy way to validate the certificate public and the certificate public key. Then it does also some extra functionalities, for example, reporting or falling back of public keys. So let's see how we can implement it. The implementation is very easy, and it doesn't like require many lines of code, and that's why I'm here today, because I do not understand why none of you, or probably like 5% of you, are not implementing SSL pinning in your apps. I mean, after public research, I found out that around 85 to 90% of application app store do not use SSL pinning. So that's like very curious thing. So how can we implement this? First of all, you need to download the certificate from the, let's say, provider which you are using. Then you have to convert it into a PEM file. Then you have to extract the public key. But don't worry, there is a Python script that TrustKit is like offering, so you can just download it, run it, and it gives you run it on top of the certificate, .pem, and it will just give you the public key. And then, of course, you have to set up TrustKit in your iOS project. So let's see how does it look, the setup. So you have just to initialize this TrustKit configuration, in which you specify the domain of your API. So in this case, it's the moviedatabase.org, expiration date of the certificate, and then, because once again, I want to remind you that we are going to see how to do it with public key and not with the certificate itself. So you put over there the public key, and as it's an array, you can even specify extra fallback public keys. So in this case, AAA is like the movie database offers only one public key, so you cannot do any other fallback. So this like little tiny piece of code is only for the initialization that you can put in the app delegate. And that's basically it. Now let's see how the pinning validation looks like. So maybe who is familiar with the URL session knows like most of the delegates, and this is like just native URL session delegates, but with a little extra code that is from TrustKit that is automatically handling the pinning validation for you. So just this if line of code is performing the pinning validation, and that's it. Guys, you do not have to write any line of code, so I don't understand why you do not use it. So I hope that today, after looking at this, you will like just implement it or give it a chance to implement the pinning validation. It is very easy, so I'm not going to show you like any giant code of networking requests or whatever, because you just specify your URL session, you initialize it, and that's it. But what I want to show you today is a demo of how we can perform a man-in-the-middle attack, and how does it looks the response from the API, and how we can modify it on the fly. So this is an article that I wrote, I think, 2 or 3 years ago. It's available on Medium. I just put a QR code for your reference, so you do not have to shot pictures of slides or watch the video once again for see the code, so you can just scan it and that's it. So now just give me 1 second so I can connect my phone. I'm using Proxyman for check what is going on from the networking point of view. Let me resize it a little bit. What's going on my phone from the networking point of view. Just bear with me, because the other program that I was using today just died 3 days ago. And so once I opened this morning, after that I woke up, I was like, okay, which app am I going to use for the demo today? And I just tried it, and it wasn't working. I was like, oh man, what I need to do now? So I just switched to this program. It's good, but I'm still a bit lost into the interface. So today we're gonna analyze this app that is called Kernel. It was, I don't know if somebody knows it, but it was mentioned like into 2021 or 2022, like WWDC, about one of the nicest design or designed icon or something like that. Anyway, as you can see, once that we open it, we add some API, the movie database.org. They are orange and they look protected because here there is like no response, and even into the header you could see only that it's connecting to the movie database.org, and that's it. You don't see which is the path, which is the version, and so on. But if we enable SSL proxy on this API request and we refresh the data that are coming from it, now we can see much way more information. That's why, that's because they do not do SSL pinning. So even though it's an HTTPS request, so S stands for secure, supposed to stands for secure, right? But you could do a man-in-the-middle attack, change the certificates, and now you can see what's into the request. So you can see here, for example, in the user agent what is going on, and you can see the full path of the API request, as well as the API key. Hopefully I will not be sued, but anyway, it doesn't like cost them anything because the movie database offers it for free. So yeah, you can see over there the full response coming from the API. And I will show you now how you can even change the response code on the fly. For example, I believe that into the upcoming section, we do have this, the last days of humanity. So over here, we have like this title, right? We are gonna enable a breakpoint, if I remember how to do it, because it's like new for me as well. The tools kit, right? And then breakpoints, yeah. Rules or breakpoint, nope. Tools, yeah, breakpoint. So now we have like the breakpoint enabled for this request, but we do not want the request, but we want to add it on the fly, the response. So now that we have it added, we can just reload once again the list of movies. And as you can see now, it's popping up the request. And we have an execute button, continue and abort. So this means that we can modify any parameter into our own like response, push execute, and let's see the magic. And here we are. We just modified the title of this movie that is coming from the API. So right now you're thinking like, oh, that's so stupid. Yeah, we modified the title, and what for? Yeah, I can see some eyebrows like going up there. Actually, this is just a stupid example, but you could have some application that do in-app purchases or subscription validation on their server. They do not do SSL pinning, so you can just switch the Boolean flag to is subscribed to true or false, and you have like pro features. Or even more, like some very important, I cannot say the name, otherwise, yeah, I do not want to end up in legal troubles. Streaming platforms, not Netflix, of course, they do not use SSL pinning, so you can basically do this and get their MP4 video or whatever else stream, download it, and do whatever you want with them. Of course, like watch it by your own, not upload it or stream it wherever, somewhere else. So I hope that this was like interesting for you. And thank you. Here you can find, once again, the link to how to perform SSL pinning. And over there, my Twitter, if you want to just hang